I want to show you how you can create a real-time cloud machine learning model on your time series data coming from a Pi system, an edge data store, adapter, Aviva Historia, Aviva MES, and more. And we're going to be starting with data that's already been synced from on-premises into the sequential data store of Connect Data Services. You can see as I scroll through here that there's some specific streams I'm interested in, my accelerometer streams and my temperature streams that are related to a piece of equipment that I want to use Connect modeling and analytics for in order to determine advanced alerts of any anomalies. And I'll do this by creating a digital twin of that asset in modeling and analytics. And the first step is here in the Twins admin to hit New Twin and to give it this new name, description, and friendly ID. And this twin is going to have properties mapped to it. Those properties are going to be real-time streams from Connect Data Services, and those streams of Connect Data Services are coming from my on-premises physical piece of equipment. And so you can even see here, I select that Connect Data Services is the source for this twin's properties. Yes, it's active. And before I hit confirm, in the future, I can even set up default notification recipients for when I do email and SMS alerts based on this twin. But at this point, I'll hit confirm, and I'm all done creating this twin. Now, there aren't any properties mapped to this twin. If you look in the bottom left, you can see I don't have any models, don't have any threads, and I have no properties. So to add properties that are related to this twin's operation, I'll hit Connect Sensors in the bottom left. Under Data Source, I'll select my data source, and here I can do searches, I can do filters, but in my case, I'll just scroll down through and drag on Connect Data Services streams to be properties of this digital twin, in this case for my piece of rotating machinery. So I have these three properties for my X, Y, and Z acceleration. I also want my temperature readings too for my OPC UA server. It's also in Connect Data Services. So I'll scroll down to my OPC UA streams. They are right here. A little bit further down, I can find my temperatures. Perfect. So I want my chassis temperature and my board temperature. So I'll drag these over to be properties. Excellent. And these are going to define the behavior of this twin. Now I'm going to train a model on the data for these properties next. So with all these mapped, I've gone ahead and I've created my twin. Now that I've gone ahead and added these properties, I'll hit continue in the top middle to go through a couple other steps. Because digital twins can be related to multiple different aspects of your organization, to pieces of equipment, to products. In this case, it's not a piece of continuous production equipment for a continuous process. So no, this twin isn't related to making products. It's also not a piece of continuous manufacturing equipment, so it doesn't go through different manufacturing or operational states. And there is not an associated rate stream. But this shows me that yes, I could absolutely apply some of these models to looking at quality and doing predictions for my continuous processes. Now finally, I'll click to create a model for these properties. And now you can see modeling analytics has lots of templates and pre-configured solutions for you to let you quickly bring the concepts of AI machine learning to your industrial data in a no-code experience. In my case, I want to detect anomalies for this asset, so I'll simply hit the detect anomaly template. I'll give it a name and I'll paste in a description that I've got ready and hit continue. And now I'm creating my first ever machine learning model right here in the cloud. You can see I'm going to still need to map some properties to it because I don't see those in the top right. So when I'm configuring this model, the first step in this chain of different quick start steps is to add data. And here again, I can do filters, I can add all of these. Just to illustrate it, I'll drag these on one at a time. I don't have to select all of the properties from my twin. In this case, I will. And I'll just show you how easy it is to drag and drop all these. Of course, if I really wanted to, I could also just hit the add all properties button in the top left. But in this case, perfect. I've got all the properties that are going to define the behavior of this twin. I'm not going to be segmenting it by product, so I'll delete that and hit next. I could do data filtering right here in the cloud. But again, just to show how easy this example is, I'll remove that, hit next. And finally, yes, I'm going to be outputting an anomaly score that I can trend and use for my predictive alerts. So perfect. I'll finally hit next and complete, and I've defined which inputs are going to go into this model. Next here, I need to set the timing for it. I need to figure out what's the time range for collecting data to train this model. That includes a good operating range of behaviors and incidents for this piece of equipment. So perfect. It's going to give me a wizard that gives me some defaults, which I can tune, but right off the bat, these are pre-configured to be a useful time range. At this point, I'll hit validate. It'll validate that I have the right number of tags brought in, that those tags actually have sufficient data. It'll test connectivity to those. My verification is completed, and now finally I can hit start training. When I hit start training, it'll let me know the interval that I pre-selected, 30 days to 1 hour, and training's begun. And what this is going to do is modeling analytics is going to reach into the sequential data store right here in Connect Data Services. It'll grab the data for these streams that I've configured as properties of the twin, now properties of the model. Since these are linked right here in modeling analytics, it'll grab the data and use that to train the model to understand the behavior, which I can then use later on when I'm operationalizing it and determining that anomaly score. So I'm going to speed up this piece, and you can see in the bottom, we're going to go through these states really quick. Altogether though, this process of training the model for this particular piece of equipment took less than 6 minutes. So again, bringing the idea of AI machine learning to industrial users in a very streamlined, straightforward, point-and-click manner. Or you could, of course, customize this yourself if you wanted, but in this case, it's already done. So my training is complete. Now let's review results. And here, modeling analytics is going to help you digest and understand what exactly went on behind the scenes during that training. There's descriptions to how it prepares the data. You can look into the individual segments that the model ran through when it's inspecting each of those different properties that I mapped in as my twin. I can even inspect the training data that came into it. In this case, looking at a trend line chart for this particular accelerometer reading. And then finally, I can learn how it's exactly determining these operating ranges and see those ranges myself right here. Again, it does a kernel density estimate of that incoming data that's coming from sequential data store. At this point, I'm finished, and at my conclusion, I can either view all analyses if I want to dive into this, or I can go ahead and start running this model. So again, we're talking just a handful of minutes altogether, less than 50 minutes, to get to the point where now we're looking at understanding our data, reviewing it. We're at the conclusion where we're ready to actually enable this model to run. So back in the quick start, as the final step, I'll hit operationalize in the bottom right. I'll use the recommended step here, which is just to run it continuously. There's other advanced steps that I could do as well. And I'll set my time interval when it's going to start and enable diagnostics and hit confirm. And at this point, my model's training succeeded. It is actually executing, and I have just created my machine learning model in the cloud using my sequential data store data. Now in the bottom right, I could go to my alert configuration. Down the road, I could set up real-time alerts and notifications to deliver me specific alerts when this anomaly score exceeds a certain threshold to give me those advanced notifications. But at this point, my twins have been configured, my model's active. Getting back to the quick start, I can see that, yup, it's running, it's been trained, it's set up to execute. And I can even see, if I go down to the anomaly score, I can see what anomaly scores have been generated in the past for this piece of equipment. And I can see how its behavior has been, what the model has determined, which actions have been anomalous, which days or which times, moments in time have actually been a little bit unusual based on that training data. By default, it gives me this 1 day time range, but I'll change this and I'll look at several days. Sure enough, you can see here, yes, the anomaly score has been spiking a couple times in the past. My operators and engineers have been reporting seeing some unusual behavior, but yes, it turns out that their intuition was exactly correct. There have been some interesting issues with this piece of equipment, and now I have a numerical score that can be computed in advance, continuously, 24/7, 365, using this twin that I just created, using that data that I mapped as its properties, and now using this anomaly detection model to give me those advanced alerts for when this piece of equipment needs additional attention prior to a failure. And this is how easy it is to create a machine learning model in the cloud, using your on-premises data that's going to deliver actionable and impactful results, early anomaly scores that let you take action to safeguard your critical equipment, and even to do so much more. Thank you.